Hi everyone, welcome to my channel. My name is Fikret. This video continues video tutorials dedicated to learning Microsoft Fabric. Two of the most important concepts in Microsoft Fabrics are One Lake and Lakehouses. As I mentioned in the introduction to data engineering service, Lakehouses are based on Delta Lake technology. Now, Delta Lake technology is relatively new technology, but it's a great technology which allows you to treat your file system like a database. Today, I'm going to cover two great features of Delta Lake, time travel and change data feeds. Join me to learn more. So this tutorial has two parts. In the first part, I will be exploring Delta time travel feature, and in the second part, I will move to change data feed feature. The reason I brought these two features together is that they are interrelated and have some similarities. So here is a quick preview of Delta time travel part. I will start with the overview of Delta time travel feature. So I will explain how Delta Lake technology handles table transactions. Then I will explain how this helps you to achieve table versioning and time travel. Then we will discuss some typical use cases. Then we'll move to command syntax. So you can browse your table history using either Spark SQL or Python or some other languages. So I'll explain different syntaxes. Then we'll move to table history management discussion, where I'll explain how you can use vacuum command to clean up old history. In a demo section, I'll explain how you can browse change history. Then I'll demonstrate how you can review past versions of table, either using versions or timestamps. Then I'll show how you can restore the table to the previous state. So that could be useful if you want to roll back your recent transactions. Then we'll talk about different options for vacuum command. I'll explain vacuum command's basic usage, and then I'll explain how you can override minimum retention configuration for vacuum command. In the second part of this tutorial, I'll start with the overview of change data feed, and we'll explain how change data feed works. Then we'll discuss some use cases for change data feed. Next, we'll move to command syntax. I'll explain how you can enable and use change data feed. Next, we'll have brief discussion around these differences between time travel and change data feed. In a demo section, I'll demonstrate how you can enable this feature on selected tables, and then I'll show you how you can read recent change in a batch mode. Finally, I'll wrap up with a demonstration of how you can stream your changes to Delta Lake table destinations using Spark structure streaming. So this could be helpful to build continuous real-time pipelines. Let's get started. So what is time travel feature and how you can benefit from that? So time travel is based on table versioning, which is one of the core features of Delta Lake technology. To understand how it works, we need to understand how Delta Lake technology handles table updates. So if you worked on implementation of transaction on files, you will remember that updating certain parts of the files are quite problematic. In many cases, people overcome these problems by introducing new versions of files rather than changing particular parts. And Delta Lake technology uses similar techniques. So it creates a transaction log folder called Delta Lake, and within this transaction logs, it will track history of change to your files. So I have provided some sample here where you can see that, for example, table created, it will add log about adding file. And then when you add rows to that table, it may add another file. And then when rows has updated, it may remove certain files and introduce new files. And when you read this table, Delta Lake technology would create current state of your data based on your data files as well as transaction logs. So how you can benefit from time travel feature? I have listed here few useful applications. So you can use it for audit purposes to understand who has changed your data, when it happened. You can also use it for data troubleshooting if you see some irregularities in your data. Next, you can use time travel to restore to tables' previous states. In other words, you can roll back recent transactions. You can use time travel for ETL logging. So this is something that I'm going to demonstrate in demo section. Because table versioning logs contain some important transaction details, including timestamp, transaction statistics like number of files or number of rows changed. So that information can be preserved and used as an ETL logging mechanism. Another useful application could be transaction consistency. So in some cases, if you have a script which applies multiple transformations, it could be useful to refer to the same version of the rows, and you can achieve that by using versioning techniques. Finally, you can manage your table history for data regulation compliance. This could be useful if you want to remove some PII data, for example, which should be cleaned up after certain customers are removed from your system. Let's take a look at time travel command syntax. One of the most useful commands for time travel is describe history command, which allows you to see different versions of your table alongside with key transaction details. Then you can review the previous version of your table by using either timestamp or version clauses. So I have provided a few examples here. So this is SQL syntax. I also provided Python syntax, which is very similar. As I mentioned, in some cases, you may want to roll back to the previous state of the table, and you can achieve that using restore table command. And as you can see, this command could be based on version or timestamp. So you may ask, where can I take exact version and timestamp information? And so you can get it from describe history tables, as we will see in the demo section. Let's talk about how you can manage table history. You can use a vacuum command to clean up your past histories, and to use that you have to specify table name as well as retention period in hours. So that's an example I provided here. By default, you can clean up any history beyond 7 days. Now, if you want to clean up more recent history, by default, Spark won't allow that. And the reason is that table history and the logs are vital in supporting your data integrity and transaction health. So to give you an example, if you try to clean up very recent history, some of your transactions may fail, or you may have some data issues. So you can view it as an insurance mechanism. However, you can override this setting, and I have provided command here, and I will show how you can do that in the demo section. All right, I am in Microsoft Fabric, and I navigated to one of the existing Lakehouses. For the purpose of this demo, you will need to have two artifacts, so data file, CSV file, and the PySpark notebooks that I am displaying here. You'll find both of them in the video description. So let's start with data file. So you'll need to upload it into unmanaged section of your Lakehouse. In this case, I have uploaded in the subfolders landing, and I have CSV subfolder under that. But you can upload it into any folder. Make sure that you get the relative path of that file as soon as you have copied, and then you need to replace relative path inside the first command of this notebook, so that my first command reads in the data frame and writes in the sales order header table. Okay, so let me run this. So that will create sales order header table, and I'm gonna display this content of this table. So this CSV file has been extracted from sales order header table from Adventure Work database, which you can create as a sample database within Azure SQL. It's pretty small table, and it represents sales information as the name implies. My next command creates Python function to update subset of rows within the table. So I am using filter function here for selected customer, and then I've assigned order delayed string to comment field, and then I assigned current timestamp to modified date field. My next command creates delta table object using delta table APIs for paths method, and then I'm using merge method for my delta object to merge into destination table using source data frames that I have created here. So let me run this. Okay, now that we have function to apply merge transformation, I'm gonna call it for different customers in my next cell. So let me run this. And let's review our change history using describe history that I have described earlier. Okay, so I've got three versions. Version 0 was created when the table has been created, and it reflects original state of the table. And then I've got two versions corresponding to transactions that I applied earlier. So if I scroll to the right, I can see the version number, timestamp, when this transaction happened, user ID and the username information, and then I can see operation type. So in this case, I've applied the merge transformation. Operation parameters column contains extra details related to merge operations. So if I expand this, you will see conditions that I have applied for merge statement. So in this case, you can see keys. And then if I continue scrolling to the right, you can see isolation level, which is by default always serializable. And I can see operation metrics. If I expand this, so this column has a lots of good information like number of target rows copied, number of output rows, number of target rows updated, number of target rows inserted, and you will also see number of target rows deleted. So lots of good information that can be used as part of your ETL jobs logging. So let's pick one of the rows and review its states at different versions. On my next command applies filter to my data frame, and it should show me my most up-to-date version of the data. So if I scroll to the right, I can see that comment field has been changed. Let's say I want to see the same row's state at version 0. For that, I'm gonna use similar read command. However, I will add version as of method here, and I'll specify the version at which I want to browse my table. So this will show me my original state of my table. So if I scroll to the right, I can see the comment field was empty. Now that we know how to review previous states of Delta table, let's take a look at restore table. As I mentioned, restore table command is useful when your table has changed because of some mistake and you are certain that you want to return back to certain versions. So in this case, I am returning to version 0, which was original version of my table. So if I run this and my next cell displays that particular customer's values, and if I scroll to the right, my comment field is empty. Okay, now that we know how change history works, let's see how we can use information content in different columns of describe history command for the purpose of logging ETL statistics. So my next command creates a data frame from describe history and selects certain columns from that. So I have included timestamp operations. Of course, you can include any other columns as well. So I have included timestamp operation, some of the subfields that can be found under operation metrics. So in this case, number of output rows, number of inserted, updated, and deleted rows. Of course, you can include any other columns that are part of this reach field. So if I run this command, I'll get then I'll get lots of good information which describe what happened at my particular transaction. And once you have created this data frame, you can write into some permanent data table which can serve you as an ETL statistics logging table. Okay, so let's explore vacuum command now. So vacuum command is straightforward. You have to specify table name and hours of which you want to retain. So 168 hours is default, so that's amounts to 7 days. And so my next cell says remove all the history above 178 hours. So in my case, because I just created this table, there's not much history to show. And the next cell tries to remove all the history above 1 hour. So if I run this, it will error out. And that's because by default, Delta Lake does not allow you to reduce change history below 168 hours. And if I take a look at the error message, it says it provides recommendation on how you can overcome that. Of course, there is a risk associated with that. If you have ongoing transactions, you may lose some data. However, in cases when you are confident that you can reduce your change history without affecting your data, you can apply this setting, which my next command does. So in this case, I am turning this retention duration check enabled setting to false. And if I run the same vacuum command subsequently, then it will clean all my history without any error. So what is change data feed? Change data feed is a similar to time travel feature, and it works hand in hand with time travel. So change data feeds purpose is to capture data change, as the name suggests, but it captures this change on a row level rather than on an entire table level. This feature is not enabled by default, but there are commands that you can use to enable on a specific tables, or you can enable it for all of your tables at once. So change data feed works similar way to time travel, but it creates a separate folder within your root data location. It's called change data, and it collects relevant logs within that folder. So how can I read change data feed? Once enabled, you can use either batch mode or streaming or real-time modes. I'll explain read syntax shortly. So how you can benefit from change data feed? Some of the change data feed applications are similar to time travel, so you can use it for audit purposes, but you can also use this to build incremental pipelines. There is a relationship between time travel and change data feed. As I mentioned earlier, change data feed syntax requires start and end row versions. So what are the key differences between time travel and change data feed? So I already mentioned that these features keep track of your changes in different log folders. And the log granularity is also different. So for time travel, logs contain table level changes, whereas change data feed tracks data on row level. Another key difference is enablement. So time travel is a key feature of Delta Lake, so you cannot enable or disable that. However, change data feed needs to be enabled manually by certain commands. So let's talk about change data feed command syntax. You can enable change data feed either when you create your table, and I have included syntax here, so you need to add table properties clause, or you can apply the change to your existing tables by using alter table commands that I have provided here. Alternatively, you can also enable change data feed for all of your tables by applying this configuration change that you can see here. So how can I read your changes? You can read the changes in batch mode. So I have provided PySpark and the Spark SQL flavors of that. So you can see that it requires start and end versions. You can also use streaming APIs, which you see at the bottom, which has a similar syntax. I'll demonstrate both options in the demo sections. All right, demo part. Let's put all this knowledge that we just learned into practical appliance. So I have navigated to the second part of the notebook that we have been discussing at the beginning. Before we continue, we may need to upgrade to latest Fabric runtime and the Spark version. You can do it from workspace settings. So let me quickly demonstrate that. So if I navigate to workspaces and click the three dots and select workspace, and then I can select data engineering science and select Spark settings. Next, navigate to Environment tab, and here you will see your current runtime. So make sure that you have at least 1.2 version, because some of the commands that I will be demonstrating did not work on the previous version of the Fabric runtime. As I mentioned earlier, to use change data feed, first of all, you need to enable on the table. So you can enable that feature when you create the table. So I have provided some sample script here. As you can see from this command, the only addition to standard table creation command is this part, which includes table properties. Table properties can include many other options, but in this case, I am using this to enable change data feed. If your table already exists, which is case for me, you can use alter command and add similar table properties clause. So I already ran all this command to save the time. Now I'm gonna walk you through this command. So in my next cell, I apply a number of different transactions to sales order table. So my next command brings table versioning history, and as you can see from operation column, I have applied change data feed operation on a version 4. So this is important because when you provide start and end versions for change data feed command, which we'll explore shortly, your versions should start at least from the version where you have enabled change data feed. So in this case, it's 4. And let me scroll down. And so here on the next cell, I demonstrate how you can use batching APIs to read recent change. Notice that I am using standard read APIs, which reads the data to data frame. The only difference is here at lines 2 and 3, where I say read only change data feed rather than entire table, and I specified table versioning start, which in this case 4. You may want to include ending version as well in certain cases, but in my case, I just want to show all the change since version 4. So the query result is very similar to what you would see from normal table read command, except these few columns at the right-hand side. So let me describe the 3 columns that change data feed adds to the results. So the change type column contains type of transaction or change. In case of delete and insert, you will simply have one version of the rows because of nature of this change. However, in case your rows have been updated or merged, you will see 2 feeds for the same change. So these 2 feeds reflects the state of the row before and after the change. So the first row in this case reflects what was the state of this column, for example, before the change, and update post image feed shows what happened to this record after the update transformation. So this is important detail because if you are transferring your changes to build incremental pipelines, you may want to choose only one of these feeds for update transformations. Okay, so my next command demonstrates how you can use Spark structured streaming to stream change data feeds to another Delta table. So Spark structured streaming is great and powerful tool. And I have few videos that I will be including in the description of this video. in case you want to learn more about that. But I'll just explain high level what's going on here. So this command will remind you batch change data feed syntax, except I am using read stream API here. And then once I read the stream, I use write stream command to write into the destinations. And then I use some of the important attributes of stream, like destination path, checkpoint location, which must be specified when you are writing the stream to some destination. And then my next command just starts the stream and assigns the handle to some variable. In the next cell, I use that streaming handle to inquire the status of the stream. So if you run this command shortly after your stream starts, you will see that some records indicating progress of your stream. My next command applies updates just to test how the streaming works. And I am using the functions that I described earlier in the time travel part of the demo. So results of my stream is being written to sales stream table. And in my next command, I am just reading this table to see how change data feed have been transferred to this table. At the end of this notebook, you will find a Spark SQL version of change data read commands. So in this case, I have two flavors of this. So the first part is using basic table change alongside with table versions. The second version is similar, except it's looking for tables file location rather than table name. That concludes today's discussion. To summarize, we have looked into Delta Lake time travel and change data feed, which are similar but slightly different features. We have learned how you can use these two great features to address some data engineering challenges. I hope you enjoyed. Thanks for watching, and I'll see you in future videos.